Welcome to a video in which we're going to look at a classification model and then establish some metrics around it. So in front of us is a confusion matrix. And what we won't focus on here is how to build this based on information about the model. We'll cover that in another video, but we'll start from this position in which we already have this data. And what this is really showing us is what the model predicted, how many times it predicted each of the two possible outcomes, and also what the true results were based on this set of records. And the question here is whether a household will renew its Lobsterland membership. There were 1,218 total households included in this model. In the predictions here are covered down the rows, and the actual results are shown here across the columns. That's not the only way this could be set up. That could be transposed, but the way it's shown here is totally fine. And from this, we can read into the model results. We can see, for instance, that there were 863 households for which the model predicted they would renew. There were 355 households that the model predicted would not. And we can see that among the 863 that the model said would renew, 612 of those truly did, 251 sadly did not. We can see that among the predicted non-renewers, 151 actually did renew, but 204 did not renew as predicted by the model. So the times when these match up, if you look at like the 612, that's the number of times where the prediction and the actual are the same. And the 204 here is another instance of that, where the prediction was non-renewal and the actual result was non-renewal. Those blocks or boxes or cells, those represent the times when the model was accurate. Across that bottom row, we see total, and we can see the true outcomes. There were 763 actual renewers and 455 households that did not actually renew. So from that basis, there are many metrics we can develop. In this video, we're only going to focus on 3, but in another video, we'll get into some other ones. And we'll start with one that is probably the most basic and the thing that a lot of people would assume matters the most when they're just starting to look at classification models, and that's accuracy. And I say that second point about accuracy there just because it turns out that in many real world machine learning classification models, there is a class of interest that the model, that the maker of the model seeks to be able to identify. And it actually may be the case, in fact, it's often the case, that accuracy is not the primary aim of the model. There's another aim of the modeler, and we'll get into that more as we dive into things like sensitivity and specificity in the next video. But for right now, we're going to just look at the ones shown here on the slide. So we'll start with accuracy. And to determine the accuracy of the model, what we need to do is we need to sum the number of times in which the model was correct, and then just divide that by the total number of predictions made. So that is going to be, in this case, 612 plus 204, and we're going to divide that by the total number of records in the model, and that is going to give us something that will round slightly. So we've got this sum, 816, we're going to divide by the 1218, and it's 0.66995. So among friends, we're going to round that just up a bit, and we want a percent. We don't want those symbols. We want, I got to get it here, a percentage symbol. There we go. Okay, so error, you might say, well, don't we already know the error? Like if we know the accuracy is 67%, isn't the error just going to be 33%? Well, spoiler alert, yes, it is, and you're right to say it. But we can also see that we can get the error by summing the instances in which the model was wrong. So we see here there were 151 times in which the model predicted non-renewal, said this household won't renew, but in truth, the household did. And there's also this 251 here, which represents instances in which the model predicted renewal, but the result was non-renewal. So what we're going to do is sum those up the 151 plus the 251, and we're going to divide that by 1218, and here it comes. Yes, 33% is what we get, but that's how we get it. And then next, we'll delve into just one of those other metrics, and we'll just, for the purpose of this video, we'll use precision. And precision is asking this question: when the model predicts the positive class, how often is it right? And just to take a moment with that, I want you to put aside any connotations you have regarding the words positive and negative. In a binary classification model, one class is going to be labeled as the positive class, another as the negative class. But that does not mean that it doesn't mean that the positive class is one that is preferred, or that the modeler wants people to be. I mean, think about like a positive result for some kind of a medical ailment. You probably would rather not have it, right? So it's in fact often arbitrary. I mean, if the model was predicting, do you prefer tea or do you prefer coffee, that is, it's arbitrary, right? But in order to use a metric like precision, you've got to label one of the classes. And so here we're labeling the renewal class as the positive class. So in order to answer this metric, so this question about precision is saying, when the model predicts the positive class, how often is it right? So our denominator is going to be 863 because we're only focusing on cases in which the model's prediction was that the record would belong to that class. So what we're going to say is 612, the 612 of the 863 times, the model was in fact right, and that the household truly did belong to that class. So here we'll just use a single decimal point for precision, and we get 70.9%. And you might wonder, well, who cares about that? Why is that? Why might someone be interested in that as opposed to, say, overall accuracy? I'll give you an example that I know I can relate to, and it's spam email filtration. So I depend on email every single day, probably like you also do. But I know that I would much rather have a spam message land in my inbox, as they do from time to time, than I would to lose a genuine message to my spam folder, which has also happened to me from time to time. So in a model in which spam email was labeled as the positive class, I would want that model to have a very, very high precision rate. And in fact, precision would be even more important to me than accuracy. So that, in other words, when the model or when the model or when my Outlook inbox labels a message as spam, I really, really want it to be right. I want the percentage of times that it labels an email that way, in which the email really is spam, I want that percentage to be very, very high. I want it to be close to 1. And I'm willing to tolerate mistakes around that, right? I'm willing to tolerate less overall accuracy in order to really be sure that a true message is not lost to my spam folder. So, but there's many other instances in which we might care about it. That's just one. But for now, we'll just focus on defining what does it mean to talk about model precision. And it's shown there on the slide, and you can see the numbers here that come from this particular confusion matrix to support that. So thanks very much for watching, and that is a look at 3 particular metrics. Don't forget to like and subscribe, and have a great day. Thank you.